Hello everyone, welcome to the Add Columns Seamlessly with TiDB's online DDL session. It's Tony from PingCap Education. Today, we will be introducing fast adding columns online in TiDB, how they contribute to the real-world use cases, and including some hands-on demonstrations. You might find later that this demo looks similar to the less index locking during online DDL demo. In fact, it is different. Adding indexes is a DBA operation. It is not relevant to the business. However, adding a column is usually strongly related to the business, and it is very likely to be a developer request. Schema change is actually inevitable for many companies. Launching new products or new marketing campaigns may require new columns to be added to the table. NoSQL databases management systems can sometimes come to the rescue. But NoSQL has its caveat. Non-standard API means the engineering team has to learn new stuff, and the code has to be fully updated. Also, by using NoSQL databases management systems, without proper management, the schema can easily become too complicated. And very soon, no one can even have a vague idea of what the schema looks like. DBMS without adding column online features may be a nightmare. Whenever you need to add a column, the entire table needs to be locked, meaning the table can no longer accept DML requests. Your business has to be stopped. Let's now look at how some of the real companies deal with this. Company A is a very large sportswear company. In their data system, it has a table. This company launches campaigns quite often to boost the sales. Every time a campaign comes, they will add a column to the table. However, their database does not support adding columns online. So what they will do is in the midnight, when they suppose there are fewer customers making orders, they will create a new table, and then copy the data from the old table to the new one. They cannot simply lock the old table and add a column. This is because their system should be able to take orders 24/7. They have some extra tricks, such as Apache Hudi and Redis, trying to minimize the impact. But those solutions do not meet their expectations. Company B has a slightly better solution. Company B is a company providing monitoring services. It monitors the hardware and software status, as well as the temperature, in a data center. When they design their table, they put a few empty columns there, column 1, column 2, and column 3 with different data types. When they need an extra column, they can just use it. And then, they have a documentation, explaining what each column means. But this is only a temporary solution. The predefined empty columns will be used up eventually. Also, predefined columns cost unnecessary overheads. In this demo, I will show you how TiDB deal with online adding column requests. I will show you TiDB is very flexible. For different situations, TiDB provides different options for adding column requests. We will also use MySQL as a comparison. You can find all my code, program, and CloudFormation template in the TiDB Course 201 GitHub repo. Let's now look at this diagram. In today's quick demo, there will always be 4 terminals. Terminal 1, Terminal 2, Terminal 3, and Terminal 4. In the first demo case, Terminal 1 will issue a long transaction. Terminal 2 will issue an adding column command. Terminal 3 and 4 will insert to the table, and query the table respectively. In this demo, TiDB's metadata lock is disabled. Discussion about the metadata lock is beyond the scope of this quick demo. If you are interested, I am happy to have a further chat with you. What I would like to show you next is that, when the metadata lock is disabled, transactions in Terminal 2, 3, and 4 can finish without any drama. So, here we are at the terminal. In Terminal 1, let's first disable the TiDB's metadata lock. By default, it is open from version 6.5. Let's now do some preparation for this demo in Terminal 1. This includes creating a database, creating a table, and inserting some values into the table. Let's now start a long transaction. Let's insert a value. That's it. I will keep this transaction open. In the second terminal, let's add a column to this table. As you can see, the request to add a column can finish. In Terminal 3, let's insert a value into the table, which can also be finished very soon. In Terminal 4, let's query the table. All done. We can now go back to the Terminal 1, let's commit this transaction. As you can see now, the transaction encountered an error with code 8028. This is because the schema is different from the one when this transaction started. Actually, an experienced developer can handle this easily. Let's look at the second figure. When the transactions in Terminal 1 are short transactions, the application can simply retry it again. Let's look at this demo. This time, in Terminal 1, there is a Java program with straightforward retry logic. Let's start the program. Let's now issue an adding column request in terminal number 2. Pay attention to in terminal 1, although there is an 8028 error, simply retry to solve this problem. Application developers may have more sophisticated ways to handle this. As we are expecting, the DML in terminal 3 and 4 can also finish in real time. Let's now move on to the next demo. In some situations, it is possible that the long transaction in Terminal 1 is doing some important tasks, such as batch processing. You would like to give the transaction in the Terminal 1 higher priority, meaning you don't prefer a retry. Instead, it is okay for the adding column request to wait for a while. It is actually also achievable in TiDB. You can simply enable the metadata lock. Now, here is our terminal again. Let's first check the metadata lock and enable it. We are now doing some preparations. Then, let's start the transaction. In Terminal 2, let's issue a request to add a column. As you can see, it is blocked. However, the transaction in Terminal 3 and 4 can pass easily. Let's now go back to the Terminal 1 and commit the transaction. Once the transaction in Terminal 1 is committed, the adding column request in Terminal 2 will also be finished very soon. Lastly, let's look at what would happen in MySQL. Unfortunately, MySQL cannot handle this kind of situation very well. As long as the first transaction does not commit, the adding column request, as well as all the following DML requests, will be blocked. If there are a huge number of client requests, the thread pool may be exhausted. Let's look at the demo. In Terminal 1, let's do some preparation, and then issue a long transaction. In Terminal 2, let's issue an adding column request. As you can see, it is blocked now. Let's move to Terminals 3 and 4. The insert and even select query cannot go through. If there are a huge number of requests, it will be a disaster. In this video, we show you how TiDB is able to deal with adding column requests. Adding column may be an essential business operation for at least some companies. TiDB provide various options to deal with different requirement, while MySQL does not. TiDB allows transactions to perform on both the current schema version and the previous schema version, while MySQL needs to take a full instance blocking lock, meaning no transactions can cross the schema versions. I have uploaded all scripts, programs, CloudFormation template, and demonstration workflow guide to the GitHub. In this repository, I have implemented the demo on AWS. Welcome to contribute other demonstration, or the same demo on different cloud vendors. You might also be interested in TiDB's workshop for MySQL users. This workshop introduces TiDB's specific features with many hands-on exercises. It is very friendly to those who are familiar with MySQL. If there are any fundamental concepts which are not very clear to you, such as the TiDB, TiDB server, TiKV, SQL layer, storage layer, stateless and stateful, you might consider going to the PingCap training and certification site to enroll and learn the self-paced introduction to TiDB course first. Thank you so much. See you in the next demo.